the increasing order of values E by M, charge by mass. What is the shortest wavelength line in the Paschen series of lithium ion? ಯಾವುದು shortest wavelength of the Paschen series in the lithium ion? ಅವ್ರು ಏನು ಕೇಳಿದಾರೆ ಈಗ? The electromagnetic radiation with highest energy, decreasing energy is least energy for radius. Hello everyone, namaskara ellarigu. I welcome you all back to Physics Wallah once again. Students, in this particular session, we will be discussing Super 30 questions based on the chapter Atomic Structure. Okay, now let's get started. Question number 1. The increasing order of values E by M, charge by mass. The particles given are electron, proton, neutron and alpha particle. 4 particle ಕೊಟ್ಟಿದಾರಲ್ಲ, electron, proton, neutron ಮತ್ತೆ alpha particle. Alpha particle is what? 2 protons plus 2 neutrons. Is that clear? So, increasing order of E by M. So, if the order of E by M should be increased, if E by M should be increased, then mass should be decreased, alva? So, which is having least mass? Least mass ಇರೋದು ಎಲೆಕ್ಟ್ರಾನ್ಗೆ. ಎಲೆಕ್ಟ್ರಾನ್ಗಿಂತ ಜಾಸ್ತಿ ಮಾಸ್ ಇರೋದು ಯಾವುದ್ರದ್ದು? ಪ್ರೋಟಾನ್ದು. ಪ್ರೋಟಾನ್ಗಿಂತ ಒಂದು ಸ್ವಲ್ಪ ನ್ಯೂಟ್ರಾನ್ಗೆ ಮಾಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ದೆನ್ alpha particle mass is more. So this is the order of mass. This is the order of mass. Is it not? Right. So automatically E by M value. What about neutron? Neutron though charge E would be 0. E would be 0. So therefore as far as neutron is concerned, E by M value should be 0. Is that clear? Right. So now if you want to write in the increasing order, E by M increasing order ಬರಿಬೇಕಂತಂದ್ರೆ first neutron ಬರೀರಿ. E by M of the neutron is the least, that is 0. Now out of alpha, proton and electron the mass least ಇದೆ ಅಲ್ವಾ? Since mass is least, E by M should be highest. So E by M of the electron should be highest. Now the competition is between alpha and proton. Alpha ಅಂತಂದ್ರೆ 2 proton plus 2 neutron. Mass is very high. If the mass is high, automatically E by M should be less. E by M of the proton is less. Then comes what? E by M of the proton. So ನಮ್ಮ ಆರ್ಡರ್ ಯಾವುದು? ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರು ನ್ಯೂಟ್ರಾನ್, proton, neutron and alpha particle, neutron, alpha particle, proton and then electron. Is that clear? This is the increasing order of E by M ratio. So that should be what? Highest is increasing order of E by M. So highest is electron followed by proton, electron followed by proton, then alpha, then neutron. So this is our answer. Option D. Is that clear? ಕೊಟ್ಟಿರೋ ಪಾರ್ಟಿಕಲ್ ಎಲೆಕ್ಟ್ರಾನು, ಪ್ರೋಟಾನು, ನ್ಯೂಟ್ರಾನು ಮತ್ತೆ alpha particles. Out of all this, so this is the increasing. Alpha particle has got the maximum mass. So this is the increasing order of the mass. So electron has got least mass. So E by M should be highest for the electron. As far as neutron is concerned, even though ಅಲ್ಫಾಕ್ಕಿಂತ ಅದರ ಮಾಸ್ ಕಡಿಮೆ ಇದ್ರೂ ಕೂಡ ನ್ಯೂಟ್ರಾನ್ದು ಚಾರ್ಜ್ 0 ಇರೋದ್ರಿಂದ E by M of the neutron is 0. ಆಮೇಲೆ alpha comes and then the proton. So our order is neutron less than alpha, less than proton, less than electron. That is E by M ratio. Is that clear? Right. Next, select the correct statement from the following. Atoms of elements are composed of 2 fundamental particles. Only 2 fundamental particles? No. Proton, neutron, electrons are only 3. Yes or no? Then the mass of the electron is 9.1 into 10 raised to minus 31 kg. Yes. Is that clear? All the isotopes of the given element show same chemical properties. Yes. All isotopes are having same chemical properties because chemical property ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್. ಎಲ್ಲ ಐಸೋಟೋಪ್ಸ್ ಅಲ್ಲೂ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರೋದ್ರಿಂದ ಸೇಮ್ ಪ್ರಾಪರ್ಟಿ ಇರುತ್ತೆ. Protons and electrons are collectively called as nucleons? No. Protons and neutrons are called as nucleons. Dalton's atomic theory regarded the atom as the ultimate particle. Atom as the indivisible particle of the matter? Yes. ಹೌದಲ್ಲ? Dalton's atomic theory ಅಲ್ಲಿ? right? So which are correct? B is correct, C is correct, E is correct. B, C and E are correct in option B. Howdalla students? Yes. Next, if Thomson's model is correct, what would be the observation in alpha ray scattering experiment? ಥಾಮ್ಸನ್ಸ್ ಮಾಡೆಲ್ ಆಫ್ ಆಟಮ್ ಕರೆಕ್ಟ್ ಆಗಿದ್ದರೆ ರುದರ್ಫೋರ್ಡ್ಸ್ ಮಾಡೆಲ್ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಏನು ಅಬ್ಸರ್ವೇಷನ್ ಆಗ್ತಿತ್ತು? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಯು ಶುಡ್ ನೋ ಥಾಮ್ಸನ್ಸ್ ಮಾಡೆಲ್ ಏನು. ಥಾಮ್ಸನ್ಸ್ ಮಾಡೆಲ್ ಪ್ರಕಾರ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಎಲ್ಲೂ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿಲ್ಲ. ಥ್ರೂಔಟ್ ದ ಸ್ಪೆರಿಕಲ್ ಆಟಮ್ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ಎಲ್ಲ ಕಡೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿರುತ್ತೆ. ಅದರ ಮಧ್ಯ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಇನ್ ಬಿಟ್ವೀನ್ ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಜಸ್ಟ್ ಲೈಕ್ ಅ ವಾಟರ್ ಮೆಲನ್ ಮಾಡೆಲ್. ದಿಸ್ ಇಸ್ ದ ಮಾಡೆಲ್ ಆಫ್ ಆಟಮ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಥಾಮ್ಸನ್ಸ್ ಮಾಡೆಲ್. ಇದು ಕರೆಕ್ಟ್ ಆಗಿದ್ದರೆ ಅಲ್ಫಾ ರೇ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಅಲ್ಲಿ ಏನಾಗ್ತಿತ್ತು? ಅಲ್ಫಾ ರೇ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಿತ್ತು? ದೇ ವುಡ್ ಆಲ್ ಪಾಸ್ ಥ್ರೂ ಆರ್ ಹಿಟ್ ಅಂಡ್ ಕಮ್ ಬ್ಯಾಕ್. ವೈ ಅಲ್ಫಾ ರೇ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಅಲ್ಲಿ ಅಲ್ಫಾ ರೇ ಪಾರ್ಟಿಕಲ್ಸ್ 1 out of 20,000 ಪಾರ್ಟಿಕಲ್ಸ್ ಯಾಕೆ ದೇ ಆರ್ ಕಮಿಂಗ್ ಬ್ಯಾಕ್? ಆರ್ ವೈ ಆರ್ ಫ್ಯೂ ಪಾರ್ಟಿಕಲ್ಸ್ ಗೆಟಿಂಗ್ ಡಿವಿಯೇಟೆಡ್? ಬಿಕಾಸ್ ಅಲ್ಲಿ ಆಟಮ್ ಅಲ್ಲಿ ಅಟ್ ದ ಸೆಂಟರ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಮಾಸ್ ಫೋಕಸ್ ಆಗಿರುವಂತ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಇದೆ. at the center there is a certain mass occupying protons and neutrons where most of the atom is concentrated. Is that clear? ಅದಕ್ಕೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಬಾಡಿಗೆ ಅಲ್ಫಾ ರೇ ಪಾರ್ಟಿಕಲ್ ಹೋಗಿ ಹಿಟ್ ಮಾಡಿದಾಗ ಇಟ್ ವಾಸ್ ಕಮಿಂಗ್ ಬ್ಯಾಕ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಈಗೇನಾಗಿದೆ, ಆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜು ಡಿಸ್ಪರ್ಸ್ ಆಗಿದೆ, ಅಂದರೆ ಎಲ್ಲೂ ಒಂದು ಕಡೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿಲ್ಲ. ಅಂದರೆ ಯಾವ ಕಡೆನೂ ಅಲ್ಫಾ ರೇ ಪಾರ್ಟಿಕಲ್ ಅದನ್ನು ಹೋಗಿ ವಾಪಸ್ ಬರೋದಿಲ್ಲ, ಎಲ್ಲ ಅಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸು ಪಾಸ್ ಥ್ರೂ ಆಗ್ತಿತ್ತು. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಸೊ ದೇರ್ ಫೋರ್ all the alpha rays should pass through the gold foil. Yes or no? Right. Only few alpha rays should pass through the gold foil? No. 98% of the alpha rays should reflect back. Should they reflect back? No way. Is that clear? Because positive charge throughout the particular spherical atom, throughout the sphere of the atom distribute ಆಗಿರುತ್ತೆ. Nowhere it is concentrated. So that alpha ray particle hit ಮಾಡಿ ವಾಪಸ್ ಬರಬೇಕಂದ್ರೆ nowhere it is concentrated. Yes or no? Both B and C wrong ಇದ್ದಾಗ ಇದು wrong ಆಗುತ್ತೆ. So right is what? All the alpha rays should just pass through the gold foil without showing any deviation or without hitting back also, because no positive charge is concentrated in Thomson's model. ಅರ್ಥ ಆಯ್ತಾ? Right. The number of protons, neutrons and electrons in the sulfur -2 atomic numbers 16, ಮಾಸ್ ನಂಬರ್ 32. ನಂಬರ್ ಆಫ್ ಏನು ಕೇಳಿದಾರ್ರಿ? ಪ್ರೋಟಾನ್ಸು, ನ್ಯೂಟ್ರಾನ್ಸು, ಎಲೆಕ್ಟ್ರಾನ್ಸು. ಪ್ರೋಟಾನ್ಸ್ ಎಷ್ಟಿದಾವ? ಪ್ರೋಟಾನ್ಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು ದ ಅಟಾಮಿಕ್ ನಂಬರ್ ವಿಚ್ ಇಸ್ 16. ನ್ಯೂಟ್ರಾನ್ಸ್ ಎಷ್ಟಿರ್ತಾವ್ರಿ? ವಾಟ್ ಆರ್ ನ್ಯೂಟ್ರಾನ್ಸ್? ನ್ಯೂಟ್ರಾನ್ಸ್ ಆರ್ ಮಾಸ್ ನಂಬರ್ ಮೈನಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್. 32 - 16 ಎಷ್ಟು? 16. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟು? ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಎಷ್ಟಿರ್ತಾವಲ್ಲ ಅಷ್ಟು, ಪ್ಲಸ್ ಇಫ್ ದೇರ್ ಈಸ್ ಎನಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಎಷ್ಟು? 2 ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದಾವೆ. ಪ್ರೋಟಾನ್ ಎಷ್ಟಿದಾವ? 16, ಒಂದೊಂದು 2 ಎಲೆಕ್ಟ್ರಾನ್ಸು, ಟೋಟಲ್ ಎಷ್ಟಾಯಿತು? 18 ಎಲೆಕ್ಟ್ರಾನ್ಸು. ಪ್ರೋಟಾನ್ 16, ನ್ಯೂಟ್ರಾನ್ 16, ಎಲೆಕ್ಟ್ರಾನ್ 18. 16, 16, 18 ಈಸ್ ದ ಆನ್ಸರ್. 16, 16, 18 ಈಸ್ ದ ಆನ್ಸರ್. ಆಪ್ಷನ್ ಬಿ. ಪ್ರೋಟಾನ್, ನ್ಯೂಟ್ರಾನ್ಸ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರೆಸ್ಪೆಕ್ಟಿವ್ಲಿ. 16, 16, 18. ಓಕೆ. The thickness of the gold foil used in the Rutherford alpha ray scattering experiment. ಅಲ್ಫಾ ರೇ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಥಿಕ್ನೆಸ್ ಆಫ್ ದ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಯೂಸ್ ಮಾಡೋದು. ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಈಸ್ ಕ್ವೈಟ್ ಮ್ಯಾಲಿಯಬಲ್ ಇನ್ ನೇಚರ್. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಬೀಟನ್ ಇನ್ ಟು ಶೀಟ್ಸ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಅದರ ಥಿಕ್ನೆಸ್ ಎಷ್ಟು ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ ಅಂತಂದ್ರೆ, ದ ಥಿಕ್ನೆಸ್ ಯೂಸ್ಡ್ ಈಸ್ ಅಬೌಟ್ 400 ನ್ಯಾನೋಮೀಟರ್ ಆರ್ 400 × 10⁻⁻9 ಮೀಟರ್, ಅಥವಾ 4 × 10⁻⁻7 ಸೆಂಟಿಮೀಟರ್. Is that clear? 400 × 10⁻⁻9 meter, or we can write 4 × 10⁻⁻7 meter, ಅಥವಾ 4 × 10⁻⁻4 centimeter. That is 0.0004 centimeter. 0.004 centimeter ಆಯ್ತಾ? Is it there? Yes, 0.0004 centimeter is there. Is that clear? Yes. So our answer is idu centimeter alla, millimeter andre innu 10 ಬರುತ್ತಲ್ಲ. Okay. Idu 4 meter alla. So right. Our answer is option A. Is that clear? 0.0004 centimeter. Is that clear, students? Right. Next. What is the shortest wavelength line in the Passion series of lithium ion? Yaudu shortest wavelength of the Passion series in the lithium ion. Passion series of the hydrogen spectrum. Nodri, you can remember this. Li, ba, pa, b, p. Nanpittukodri. Lyman series, Balmer series, Passion series, Brackett series, P1 series. Illi n1 is equal to 1, n2 is equal to 2, n1 is equal to 2, n1 is equal to 3, n1 is equal to 4, n1 is equal to 5. Ille n2 is greater than 1, n2 is greater than 3, n2 is greater than 4, n2 is greater than 5, n2 is greater than 5. Greater than 2, greater than 3, n2 is greater than 3, n2 is greater than 4, n2 is greater than 5. Okay na? Yav series iga? Passion series. Passion series alli these are our numbers. Okay, right. Shortest wavelength. We know that lambda is equal to h into, E is equal to h into nu or h into c by lambda. By this particular formula, we can figure out that energy is inversely proportional to lambda alva. So shortest wavelength kedidare antandre you have to go for highest amount of energy. Highest energy antandre for Passion series n1 is fixed 3, n2 should be highest energy antandre infinite level. n2 is infinite. For Passion series n2 is infinite. So idakke naviga shortest wavelength anna find out madona. Namma hatra iruvanta formula wave number du, that is r into z square into 1 upon n1 square minus 1 upon n2 square. Haudalla heli? R into, what is atomic number of lithium? Lithium is 3. 3 square is what? 3 square is what? 9. 1 upon n1 square is how much? 3 square is 9. 1 upon infinity square, that just becomes 0. So 9 and 9 ಇಲ್ಲಿ ಹೋಯ್ತಲ್ಲ, ಏನು ಉಳಿತು? R ಉಳಿತು. But that is what? 1 by lambda. ಅವ್ರೇನು ಕೇಳಿದ್ದಾರೆ? ವೇವ್ಲೆಂತ್ ಕೇಳಿದ್ದಾರೆ. So ವೇವ್ಲೆಂತ್ is equal to 1 by R ಆಗುತ್ತೆ. Is that clear? ನಾವು ತಗೊಂಡಿರ್ತಕ್ಕಂಥ ನಂಬರು n1 is equal to 3, n2 is equal to infinity for highest amount of energy and least amount of wavelength ಗೆ. ಅದನ್ನ ತಗೊಂಡ್ರೆ ನಮಗೆ ಸಿಗುವಂತ ವೇವ್ ನಂಬರ್ ಯಾವುದು? 6. ನಮಗೆ ಸಿಗುವಂತ ವೇವ್ಲೆಂತ್ ಯಾವುದು? 1 by R. So 1 by R is our answer. Is that clear, students? Right. The number of protons, neutrons and electrons again. 175, lutetium 71. Protons ಎಷ್ಟಾಗುತ್ತೆ? 71. Neutrons should be 175 minus 71 ಅಂದರೆ 104. These are the neutrons. These are the neutrons. ಎಷ್ಟೋರ್ನು? Yes. Proton and neutron. And then electrons also. Electrons are equal to protons, no? ಎಷ್ಟು protons? 71. So respectively ನಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟು? Proton, neutron, electron ಕೇಳಿರೋದಲ್ವ? 71, 104, 71. 71, 104, 71. ನಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟು? Option A. Got it? Yes. A particular station of All India Radio, New Delhi, broadcast on a frequency of, frequency ಎಷ್ಟು? 1368 kilohertz. Is that clear? I'll convert that into cycles per second or hertz. That will be 10 raised to 3 hertz. Okay, that is frequency. Wavelength of the electromagnetic radiation emitted. Frequency kottidare, wavelength kelidare. So wavelength of the wave electromagnetic radiation is given by what? Lambda is equal to h into c, or h is equal c into 1 by nu, or c by nu. Yes. Okay, so therefore what is lambda now? C is what? Velocity of light. Electromagnetic radiations travel with the velocity of light. 3 into 10 raised to 8 meters per second. And your nu is how much? 1368. hertz or cycles per second. 1368 into 10 raised to 3 cycles per second. 10 raised to 3 ಮೇಲೆ ಹೋದ್ರೆ -3 plus 8 ಅಂತಂದ್ರೆ +5. So this is 3 upon, I'll make it 1.368 into 10 raised to 3 ಆಯ್ತಲ್ಲ ಇದು. 10 raised to 3 ಮೇಲೆ ಹೋದ್ರೆ -3 plus 5 ಅಂದ್ರೆ +2 ಆಯ್ತು. So this is 3 upon almost 1.4 ಆಯ್ತು. 3 upon 1.4 ಅಂದ್ರೆ almost 2 into 10 raised to 2 ಅಂದ್ರೆ almost 200 is my answer. Almost 200. So that should be 219.3 nu ide, 219.2 nu ide. Fantastic. So what we shall do here is, yes, so here 3 upon 1368 into 10 raised to 3 ಮೇಲೆ ಹೋಗಿದೆ -3 plus 5 ಆಯಿತು. Okay, fine. So this has to be 3 upon 1.368 into 10 raised to 3 and that is 10 raised to 2. Okay na? ಈಗ ಏನು ಮಾಡೋಣ, 1.368 into 2.192 ಮಾಡೋಣ. 2.192 2816 268 sorry 2816 2612 13 2367 212 9872. Okay, 9872 9654 61 9327 33 919 and then we have 12. Okay, 188 166 133 111 2816 1 2612 13 2367 212 6 ಇದು 5 8 and 8 16 6 12 15 16 17 and 18 2 5 6 7 8 on the 9 7 8 and 9 ಇದು 2. Come back 6 digits 1 2 3 4 5 6 2.998 2.192 2.192 ಏನಾದರೂ ಮಾಡಿದರೆ 2.998 ಬರುತ್ತೆ. ನಮಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ 3 ಬರಬೇಕಾಗಿದೆ. ಸೊ ವಾಟ್ ವಿ ಶಾಲ್ ಟೇಕ್ 2.193 ಮಾಡೋಣ. 3 ಮಾಡಿದರೆ ಏನಾಗ್ತದೆ ಇಲ್ಲಿಗ, ಇಫ್ ವಿ ಮೇಕ್ ಇಟ್ 3 8s 24 ಆಗ್ತಿತ್ತಲ್ಲ, ಸ್ಲೈಟ್ಲಿ ಮೋರ್. ಸೊ ದ್ಯಾಟ್ ವುಡ್ ಗಿವ್ ಅಸ್ 219.3 ವುಡ್ ಬಿ ಅವರ್ ಆನ್ಸರ್. ಇಸ್ ದ್ಯಾಟ್ ಕ್ಲಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ಸೊ 2.192 ತಗೊಂಡು ನಾವೇನಾದರೂ ಪ್ರೊಸೀಡ್ ಮಾಡಿದರೆ 2.192 ತಗೊಂಡು ನಾವು ಏನಾದರೂ ಪ್ರೊಸೀಡ್ ಮಾಡಿದರೆ ನಮ್ಮ ಆನ್ಸರ್ 2.998 ಬರುತ್ತೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ 2.193 ತಗೊಂಡು ಮಾಡಿದರೆ ನಮ್ಮ ಆನ್ಸರ್ ಡೆಫಿನೆಟ್ಲಿ 3 ಬರ್ತಾ ಇತ್ತು. ಸೊ ಲೆಟ್ ಮೀ ಕನ್ಫರ್ಮ್ ಇಟ್. ವಿ ಶುಡ್ ನಾಟ್ ಯೂಸ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್. ಐ ಆಮ್ ಯೂಸಿಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಓನ್ಲಿ ಟು ಕನ್ಫರ್ಮ್ ಇಟ್. ಸೊ ದೇರ್ ಫೋರ್ ಏನು ಮಾಡೋಣ ಈಗ, 2.193 into 1.368. This is exactly 3. 1.368 ones are ille 2.193s are 2.193 ಅಂತಂದ್ರೆ 2.193 into 10 raised to 12 ಅಂದ್ರೆ 219.3 ನಮ್ಮ ಆನ್ಸರ್ ಬರುತ್ತೆ. So this would be our answer. Is that clear, students? Right. Next, the electromagnetic radiations with a high amount of energy is. Electromagnetic radiations with high amount of energy ಯಾವುದು? Electromagnetic radiations with the increasing order of wavelength ಬರೆಯೋಣ ನಾವೀಗ. cos gamma XUV IMR ಇದು ನೆನ್ಪಿಟ್ಕೋಬೇಕು, ಸುಮ್ಮನೆ ಹಂಗ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು. cos gamma XUV IMR ಏನಿದು? ಇನ್ಕ್ರೀಸ್ ಇನ್ ವೇವ್ ಲೆಂತ್ ಒಂದು ಆರ್ಡರ್ ಇದು. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಅಂಡ್ ಯು ನೋ ದ್ಯಾಟ್ ಎನರ್ಜಿ ಈಸ್ ಈಕ್ವಲ್ ಟು H into C by lambda ಫಾರ್ಮುಲಾ ಪ್ರಕಾರ ಎನರ್ಜಿ ಅಂಡ್ ವೇವ್ ಲೆಂತ್ ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಅಂದರೆ ಇದು ಡಿಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಎನರ್ಜಿ ಆಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಅವ್ರು ಏನು ಕೇಳಿದಾರೆ ಈಗ? ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ ವಿತ್ ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿ, ಡಿಕ್ರೀಸಿಂಗ್ ಎನರ್ಜಿ ಈಸ್ ಲೀಸ್ಟ್ ಎನರ್ಜಿ ಫಾರ್ ರೇಡಿಯಸ್. least energy for radius ಅಲ್ಲ, least energy for radio waves ಅಂದ್ರೆ highest energy for cosmic rays. Where are the cosmic rays? No cosmic rays. So this is increase in lambda, highest wavelength, least frequency, least energy. I want more energy. So do we have cosmic rays? No. We are having radio waves, X-rays, infrared, visible. We are having radio waves, ಆಮೇಲೆ X-rays, yes, X-rays, yes. Infrared is here. Infrared is here. Visible is here. Is that clear? So as we come, increase in energy, and the highest energy ಇರೋದು ಯಾವುದು? Out of the given options. Cosmic ಮತ್ತೆ gamma ಅಲ್ಲ, out of the given option, it is X-rays. Is that clear? Cos gamma XUV IMR is the increasing order of wavelength. ಅಂದರೆ decreasing order of energy. ಎಷ್ಟು ಆ ಕಡೆ ಇರುತ್ತೆ ಅಷ್ಟು increasing order of wavelength. ಅಂದರೆ decreasing order of energy. ಎಷ್ಟು ಆ ಕಡೆ ಇರುತ್ತೆ ಅಷ್ಟು ಕಡಿಮೆ ಎನರ್ಜಿ ಇರುತ್ತೆ, ಎಷ್ಟು ಈ ಕಡೆ ಇರುತ್ತೆ ಅಷ್ಟು ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರುತ್ತೆ. ಸೊ ಔಟ್ ಆಫ್ ದ ಗಿವನ್ ಆಪ್ಷನ್ ಈ ಕಡೆ ಇರೋದು ಯಾವುದು? X-rays. Is that clear? Right. Assume that 2 into 10 raised to minus 7 joule of light energy, 2 into 10 raised to minus 17 joule of light energy is needed by the interior of the human eye to see an object. ಎಷ್ಟು ಎನರ್ಜಿ? 2 into 10 raised to minus 17 joule of light energy is needed by the interior of the human eye to see an object. This much of light energy is needed. How many photons of the yellow light? How many photons of the yellow light of wavelength 595.2 nanometer are needed to generate this minimum energy? Ist energy ಬೇಕು for the interior of the human eye to see an object. Suppose if you have a yellow light of this much wavelength, ಇಷ್ಟು ವೇವ್ಲೆಂತ್ ಇರುವಂತ yellow light ದಲ್ಲಿ ಎಷ್ಟು photons ಬೇಕಾಗುತ್ತೆ? How many photons of this much wavelength will make up this much of energy? Is that clear? So what is the relation between number of photons and energy? Planck's quantum theory. E is equal to n into h into nu, or I can convert that into h into c by lambda. Nu is equal to c by lambda alva, because they have given lambda. So what we want to find out? Number of photons. So what is number of photons? E into lambda by h into c. So number of photons should be E. What is the E given? 2 into 10 raised to minus 17 joule. Lambda is how much? 595.2 into nanometer andre 10 raised to minus 9 meter, divided by h 6.626 into 10 raised to minus 34 joule second. C is what? 3 into 10 raised to 8 meters per second. Okay, minus 17 ಹೋಗಿ minus 17 ಉಳಿಯುತ್ತೆ ಇಲ್ಲಿ. minus 17 plus 8 ಅಂತಂದ್ರೆ minus 17 plus 8 ಅಂದ್ರೆ minus 9 ಆಯ್ತಲ್ಲ. ಆ minus 9 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ಹೋಯ್ತು. ಸೊ ಏನು ಉಳಿತೀಗ? 2 into 595.2 divided by 6.6 into 3 ಉಳಿತು. ಓಕೆನಾ? ಸೊ 2 2s are 4, 2 5s are 10 1, 2 9s are 18 19 1, 2 5s are 10 ಒಂದು 11. Come back one digit. 1190 by 6.6 into 3. Okay, 3 6s are 18 1, 3 6s are 18 1 1 1 1 1 1, 3 6 18 ಒಂದು 19 198 ಆಯ್ತು. ಇದು 1190 by 198. 1190 by 198, is it? I don't think so. 10 raised to minus 2 into 10 raised to minus 17, 6.6 into 3, 2 into 595.2 nanometer into 10 raised to minus 9 meter. This is in joule second. 3 into 10 raised to 8 meters per second. Minus 17 gone, minus 17 is left. Minus 17 plus 8 and minus 9. Take it up. Plus 9 minus 9 is gone. 2 into 595.2. So this should be 198. 1s are almost 6s are. So your answer should be 6. Is it there? Yes. Is that clear? Let me check it again. So number of photons equal to E into lambda by h into c. E is what? 2 into 10 raised to minus 17. Lambda is what? 595.2 into 10 raised to minus 9 meter. H is what? 6.6 into 10 raised to minus 34 into 3 into 10 raised to 8. Minus 34, minus 17 gone, minus 17 is still left. Minus 17 plus 8 is minus 9, minus 9 gone. 2 into 595, 1000 something. 6.6 into 3. Very good. This is the This was how much? Around 1190. This is just 19.6. So this would be 19.6 ones are almost 60s are. Not 60 students. That should be 60 should be our answer. Is that clear? Right. Next. The energy of the second Bohr orbit. The energy of the second Bohr orbit where n is equal to 2. Energy of the second Bohr orbit of the hydrogen atom is minus 3.41 eV. The energy of the second Bohr orbit of helium ion. What is a helium ion? Helium ion has just got one electron, no? So this becomes what? Hydrogen-like particle. So they have asked you what? They have asked you, the energy of the second Bohr orbit of hydrogen-like particle. For a hydrogen-like particle, energy of the electron in the nth orbit is given by the formula minus 13.6 into z square by n square in EV. This is what is given. This is what you should be remembering. Minus 13.6. Z andre ಏನ್ರಿ atomic number. Atomic number of helium ಎಷ್ಟು 2. 2 square ಅಂದ್ರೆ 4. n square. For ಯಾವ orbit ಕೇಳಿದಾರೆ? Second orbit ಗೆ. n is equal to 2 again. Second orbit ಗೆ n is equal to 2. 2 square ಅಂದ್ರೆ 4. 4 and 4 gets cancelled. You are left with minus 13.6 EV. Minus 13.64 EV is your answer. Remember this formula. Are the students? Right. Next. In photoelectric effect, the number of photoelectrons emitted is proportional to. In a photoelectric effect, when a light of certain frequency only falls on the surface of the metal, idu on the surface of the metal iddare, only when the light of certain minimum frequency is incident on the surface of the metal, avag matra electron would be knocked out. That is called as photoelectric effect. Question in ಕೇಳಿದಾರೆ in photoelectric effect, number of photoelectrons emitted. ಎಷ್ಟು photoelectrons emit ಆಗಿರೋದು, that will depend on what? That will depend on what? The kinetic energy of the electron is directly proportional to frequency of the radiation, but number of electrons is directly proportional to intensity. How much of the light has got accumulated of a particular frequency? Based on that, the number of electrons emitted gets dependent. So number of electron emitted is directly proportional to intensity, whereas kinetic energy depends on the frequency. So ಏನು ಕೇಳಿದಾರೆ ಈಗ? Number of photoelectrons emitted is directly proportional to what? Intensity. Intensity of the incident beam, not frequency, not velocity, not work function. Intensity of the incident radiation. Based on how much of the light has been incident on that particular surface of the metal of a particular frequency, the number of electrons emitted depends. Okay now? The work function andre enri? The total amount of the energy that is required to knock the electron out. The minimum amount of energy that is required to knock the electron out. The work function, which we can call it as h nu naught. Work function of the metal, h nu naught is 4.2 eV. If radiation of 2000 angstrom, radiation, that is wavelength given 2000 angstrom, andre 2000 into 10 raised to minus 10 meter. Athava 2 into 10 raised to 3 andre minus 7 meter. If the radiation of 2000 angstrom falls on the surface of the metal, then the kinetic energy of the fastest photoelectron, kinetic energy of the emitted electron is how much? So kinetic energy of the emitted electron, the formula for that is whatever is the energy that is incident on the surface of the metal minus whatever is the energy that is required to knock the electron out. That is minus work function. So your formula should be h into nu minus nu naught. Yes or no? Right. So iga, this is, your answers are in joules. Let me convert EV into joules. 1 EV is 1.6 into 10 raised to minus 19 joule. So 16 2 32 3 3 3 3 3 3 16 4 16 4 16 4 32 64 67. Come back 2 digits. 6.78 into 10 raised to minus 19 joule. Idu the work function. H nu naught ಅವರು ಕೊಟ್ಟಿರೋದು. Direct H nu naught ಕೊಟ್ಟಿದ್ದಾರಲ್ಲ, fine, no problem. So H nu naught given is how much? 4.2p. Now let us find h nu separately. H into nu is what? H into c by lambda. What is h? 6.6 into 10 raised to minus 34 joule second. C is what? 3 into 10 raised to 8 meters per second. Your lambda is how much? 2 into 10 raised to minus 7. 2 ones are 2 3.3s are. 3.3 into 3 is 9.9. Minus 7 ಮೇಲೆ ಹೋದ್ರೆ plus 7. Plus 7 plus 8 plus 15. Plus 15 10 raised to minus 34 is minus 19. Okay, 9.9 into 10 raised to minus 19 is 9.9 into 10 raised to minus 19 is h nu. h nu not ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 6.72. 6.72 into 10 raised to minus 19 ಬರುತ್ತೆ. If you take 10 raised to minus 19 common out, you are left with 9.9 minus 6.72. So that should be how much, students? 10 raised to minus 19 ಬರಬೇಕಾ ಇಲ್ಲಿ? 9.9 6.72. 6.72 7.72 8.72 9.72 ಅಂದ್ರೆ 3.xyz into 10 raised to minus 19 joule. 3.xyz into 10 raised to minus 19 joule is my answer. That is option C. Is that clear, students? Right. Electron is present in fifth excited state. Electron ಒಂದು atom ಅಲ್ಲಿ fifth excited state. If I take the ground state as ಎಷ್ಟು ತಗೋಬೇಕು ನಾವು? First energy level. Fifth excited state ಅಂದ್ರೆ first excited state is second energy level. Second, third, 4, 5. Okay. First excited, second excited, third excited, fourth excited, fifth excited state. This is the fifth excited state. Andre, this is the first energy level, second energy level, third energy level, fourth energy level, fifth energy level, sixth energy level. Sixth energy level is your fifth excited state. How the students? The electron is present in the fifth excited state under sixth energy level in the helium atom, moves to first excited state. First excited state antandre it comes to second energy level. Andre ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ? 6 ನಿಂದ 2 ಗೆ. It is coming to 6 ನಿಂದ second ಗೆ. Okay, right. 6 to 2. So electron is present in the fifth excited state, that is sixth energy level, moves to the first excited state under that is second energy level. Number of possible spectral lines. So how many would be there? 6 energy level ನಿಂದ 2 ವರೆಗೂ 1, 6 ನಿಂದ 3, 6 ನಿಂದ 4, 6 ನಿಂದ 5. ಅದೇ ರೀತಿ 5 ನಿಂದ 2, then 3, then 4. And 4 ನಿಂದ 2, 4 to 3. Then 3 to 2. Totally how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 lines would be there. Is that clear, students? ಇದಕ್ಕೆ ಒಂದು ಏನು ಫಾರ್ಮುಲಾ ಅಂತಂದ್ರೆ number of spectral lines. Number of spectral lines. Is that clear? Delta n into delta n minus 1 divided by 2. Delta n andre it was in the sixth energy level and it is coming to first excited state. Sixth energy level, fifth to first excited state. So that means what? Delta n would be what? 6 minus first. 6 minus first would be what? 5. And delta n. So delta n is 5. Allah. Delta n is 5 minus 1 by 2. So 5 into 4 by 2. Your answer should be 10. The same question was asked for JEE mains, I guess, this time. Is that clear? Nimma answer ಎಷ್ಟು ಬರುತ್ತೆ? 10 ಬರುತ್ತೆ. Is that clear, students? Right. Next. The energy of electron in the first orbit of helium is this much. Energy of the electron in the first orbit of helium is this much. Energy of the electron in the first orbit of hydrogen. Is that clear? Energy of the electron in the first orbit of helium. Helium ge first orbital ಎಷ್ಟಿದೆ? minus 871.6 into 10 raised to minus 20 joule. The energy of the electron in the first orbit of hydrogen. Energy of the electron in the first orbit of hydrogen is how much? So I told you to remember the formula. Energy is directly proportional to what? Z square by n square. Is that clear? Proportional to Z square by n square. So if you consider energy of the helium plus divided by energy of hydrogen. This is already how much? Minus 871.6 into 10 raised to minus 20 joule. Is it not? Right. So this is Z for helium is how much? First energy level, first orbital. So Z for helium is first 1 square. N for this one. Z is sorry. Z for helium is 2. 2 square is 4. So which energy level you are going for? First energy level. So 1 square is 1. Divided by, for the hydrogen, again Z square by N square. So Z is 1 and this is also 1. So that would be how much? 4. So therefore energy of the electron in the first orbit of hydrogen would be energy of the electron in the second orbital of helium by 4. How much is given for helium? Minus 871.6 into 10 raised to minus 20 by 4. 4 1 4 4 2 1 3 1 ಅಂದರೆ 1 8. ಓಕೆ, ಆಲ್ಮೋಸ್ಟ್ minus 218 into 10 raised to minus 20 joule. Close to that. ಯಾವ್ದಿರೋದು? ಇದು ಒಂದೇ. Yes or no? So we'll go ahead with this. Is that clear, students? So remember this. You'll be able to answer this. Got it? Next. What transition in the helium ion? What transition in the helium ion shall have the same wave number as the first line in the Balmer series of hydrogen atom? So ಇಲ್ಲಿ ನೋಡ್ರಿ, Balmer series of hydrogen atom. Balmer series of hydrogen atom. Hydrogen atom ನಲ್ಲಿ first line. Balmer series of hydrogen atom ಅಲ್ಲಿ first line ಗೆ ಏನು ವೇವ್ ನಂಬರ್ ಇದೆ? ಏನು ವೇವ್ ನಂಬರ್ ಇದೆ? ಇಷ್ಟೇ ವೇವ್ ನಂಬರು ಫಾರ್ ಹೀಲಿಯಂ. ಫಾರ್ ಹೀಲಿಯಂ ಮತ್ತೆ ಬಾಮರ್ ಸೀರೀಸ್ ಅಲ್ಲಿನೇ ಹೀಲಿಯಂ ಅಲ್ಲಿ ಯಾವ ಟ್ರಾನ್ಸಿಷನ್, ವಾಟ್ ಶುಡ್ ಬಿ ದ ಟ್ರಾನ್ಸಿಷನ್ ಫಾರ್ ದ ಫಸ್ಟ್ ಲೈನ್ ಅಂತಂದ್ರೆ, ಬಾಮರ್ ಸೀರೀಸ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಲೈನ್ ಅಂತಂದ್ರೆ N1, ಬಾಮರ್ ಸೀರೀಸ್ಗೆ N1 is 2, N2 is 3. ಎಲೆಕ್ಟ್ರಾನ್ ಥರ್ಡ್ ಎನರ್ಜಿ ಲೆವೆಲ್ನಿಂದ ಸೆಕೆಂಡ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಟ್ರಾನ್ಸಿಷನ್ ಆದಾಗ, ಬಿಟ್ವೀನ್ 2 and 3 ಟ್ರಾನ್ಸಿಷನ್ ಆದಾಗ ಎಷ್ಟು ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಮಿಟೆಡ್ ರೇಡಿಯೇಷನ್ದು ವೇವ್ ನಂಬರ್ ಎಷ್ಟಿರುತ್ತಲ್ಲ ಅಷ್ಟೇ ವೇವ್ ನಂಬರ್ದು ಹೀಲಿಯಮಲ್ಲೂ ಕೂಡ ಇರಬೇಕಂದ್ರೆ, ಅಷ್ಟೇ ವೇವ್ ನಂಬರ್ದು ಹೀಲಿಯಮಲ್ಲೂ ಕೂಡ ಇರಬೇಕಂತಂದ್ರೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಷ್ಟು ಇಸ್ ಆಸ್ಟ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಬಾಮರ್ ಸೀರೀಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಲೈನ್ಗೆ ಏನು ಟ್ರಾನ್ಸಿಷನ್ ಇದೆ, ಆ ಟ್ರಾನ್ಸಿಷನ್ಗೆ ಏನು ವೇವ್ ನಂಬರ್ ಇದೆ ಅಷ್ಟೇ ವೇವ್ ನಂಬರು ಹೀಲಿಯಮ್ದ ಅಯಾನ್ದಲ್ಲೂ ಇರಬೇಕಂದ್ರೆ ಅದರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಂದ ಎಲ್ಲಿ ಟ್ರಾನ್ಸಿಷನ್ ಆಗಬೇಕು. ದಿಸ್ ಇಸ್ ದ ಕ್ವಶನ್. Is that clear? First let us find the wave number for this. Wave number is equal to what? For hydrogen ಇರೋದ್ರಿಂದ Z square ಬೇಡ ನಮಗೆ, R ಅಷ್ಟೇ ಇರಲಿ. 1 upon N1 square minus 1 upon N2 square. Or 1 upon N1 square. What is N1 square? 4. What is N2 square? 3. ಇದು ಯಾಕೆ ತೊಗೊಂಡೆ ನಾ ಹಿಂಗ? ಫಸ್ಟ್ ಲೈನ್ ಅಂತ ಹೇಳಿದಾರಲ್ಲ. ಫಸ್ಟ್ ಲೈನ್ ಫಾರ್ ಬಾಮರ್ ಸೀರೀಸ್ N1 to N2 is 3. So 3 square ಅಂದ್ರೆ 9. So this should be how much, students? R ಇಲ್ಲಿ ಎಷ್ಟು ಬರುತ್ತೆ? 6 4 9 36 36 9 4 ಅಂದರೆ 5/36 ಅಂದರೆ 5R/36. 5R/36 is the wave number. ಇಷ್ಟೇ ಇರಬೇಕಿಲ್ಲಿ. ಇಲ್ಲೂ ಕೂಡ ಎಷ್ಟಿರಬೇಕು? 5R/36ನೇ ಆಗಬೇಕು. ಅಂದರೆ ಇಲ್ಲಿ ನಾ ಏನು ಬರೀತೀನಿ? R into Z square 1 upon N1 square minus 1 upon N2 square. ಇಲ್ಲಿ ಯಾವ್ಯಾವುದು ಟ್ರಾನ್ಸಿಷನ್ ಆದರೆ 5R/36 ಬರುತ್ತೆ. R into Z square is how much for helium? ಹೀಲಿಯಮ್ದ ಅಟಾಮಿಕ್ ನಂಬರ್ 2 ಅಲ್ವಾ? ಸೊ ಇದು 4 ಆಯಿತು. ಸೊ 1 upon ಎಷ್ಟು ತಗೋತೀರಿ? ಇಲ್ಲಿ 1 upon ಎಷ್ಟು ತಗೋತೀರಿ? ಸೊ ದಟ್ ಅದು 5R/36 ಆಗಬೇಕು. ಸೊ ಲೆಟ್ ಅಸ್ ಡೂ ಬೈ 4/2 ಆರ್ 7/5. 7 ಸುಮ್ಮನೆ 7 ಅಂತ ತಗೊಳ್ಳೋಣ ಫಸ್ಟ್. 1/7 ಸ್ಕ್ವೇರ್ ಅಂದರೆ 49 ಆಯ್ತಲ್ಲ. 1/N1 ಸ್ಕ್ವೇರ್ ಅಂದರೆ ಇದು 49 ಆಗುತ್ತೆ, ಇದು 25 ಆಗುತ್ತೆ. 49 25 49 25 ಅಂದರೆ 24 ಆಗುತ್ತೆ. 36 ಬರುವಂಥ ಚಾನ್ಸ್ ಇಲ್ಲೇ ಇಲ್ಲ. ಸೊ ಐ ವಿಲ್ ಲೀವ್ ಇಟ್ ಅಪಾರ್ಟ್. 6 and 4 ಟ್ರೈ ಮಾಡೋಣ. 6 and 4. ಸೊ N1 is equal to 4 ಸ್ಕ್ವೇರ್ ಅಂದರೆ ಓಕೆ 4 ಸ್ಕ್ವೇರ್ ಆ್ಯಂಡ್ ದಿಸ್ ಇಸ್ 6 ಸ್ಕ್ವೇರ್. ಇಲ್ಲೇ ನೋಡ್ರಿ ಸ್ಟೂಡೆಂಟ್ಸ್, R into 4 1/16 minus 1/36 ಹೌದಲ್ಲ ಹೇಳಿ? R into 4 ಇದು 16 into 36 ಆಗ್ತದ. ಇಲ್ಲಿ ಮೇಲೆ 36 ಮೇಲೆ 16, 36 ಮೈನಸ್ 16 ಅಂದರೆ 20 ಹೌದಲ್ಲ. 4 1s 4, 4 4s. ಸೊ ಆರ್ 4 1 4 5, ಸೊ 5/36 ಬಂತು ನೋಡ್ರಿ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ನಮಗೆ ಬೇಕಾಗಿರೋದು 5r/36. 5r/36 ಯಾವಾಗ ಬಂತು? ವೆನ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಜಂಪಿಂಗ್ ಟು 4th ಎನರ್ಜಿ ಲೆವೆಲ್ನಿಂದ 6th ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ, ಅಂದರೆ 6 to 4. ಅಂದರೆ ನಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟು? ಆಪ್ಷನ್ ಬಿ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ರೈಟ್? ಓಕೆ. ನೆಕ್ಸ್ಟ್, splitting of the spectral line under the influence of the magnetic field. Splitting of the spectral lines are further split when the source is subjected to magnetic field. ಅದಕ್ಕೇನಂತಾರ್ರಿ? Zeeman effect. In the electric field it is called Stark effect. It is in the presence of splitting in the presence of electric field, splitting in the presence of magnetic field. So ನಿಮ್ಮ ಆನ್ಸರ್ ಯಾವುದು? Zeeman effect. Photoelectric effect ಇದರಲ್ಲಿ ಬರೋದಿಲ್ಲ. Photoelectric effect is about emission of the electron from the surface of the metal when a certain radiation of a certain frequency hits the surface of the metal. So that is photoelectric effect. ಇಲ್ಲಿ ಬರೋದಿಲ್ಲ. Splitting of the spectral lines in presence of magnetic field is Zeeman effect. Which one is the wrong statement? De Broglie's dual nature of matter wavelength is given by lambda is equal to h/mv. Yes or no? Yes. Lambda is the property of the wave, m is the property or momentum is the property of the particle. So dual nature of matter ಬಗ್ಗೆ ಹೇಳುವಾಗ this is the formula that you will come across. That is right. ಅವ್ರು ಏನು ಕೇಳಿದ್ದಾರೆ? ರಾಂಗ್ ಯಾವುದಿದೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. The uncertainty principle delta E into delta T is always greater than or equal to h/4 pi. If delta E is the error in finding the position, if delta T is the error in finding the momentum, that is always greater than h/4 pi, and that is also right. ಹೌದಲ್ಲ? Half filled and fully filled orbitals have greater stability. Yes. ನೀವು ಕ್ರೋಮಿಯಮ್ದು ಮತ್ತು ಜಿಂಕ್, ಕ್ರೋಮಿಯಂ ಮತ್ತು ಕಾಪರ್ ನೋಡ್ತಿರಲ್ಲ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟಲ್ಲಿ, ಹಾಫ್ ಫಿಲ್ಡ್ ಮತ್ತು ಫುಲ್ಲಿ ಫಿಲ್ಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಗ್ರೇಟರ್ ಸ್ಟೆಬಿಲಿಟಿ ಬಿಕಾಸ್ ಆಫ್ ದ ಫ್ಯಾಕ್ಟ್ ದಟ್ ಗುಡ್ ನಂಬರ್ ಆಫ್ ಎಕ್ಸ್ಚೇಂಜಸ್ ಆರ್ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್ ಆ್ಯಂಡ್ ದೆರ್ ಈಸ್ ಅ ಗ್ರೇಟರ್ ಸಿಮೆಟ್ರಿ ಆ್ಯಂಡ್ ಮೋರ್ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಅರೇಂಜ್ಮೆಂಟ್ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ದ ರೀಸನ್ ದೇ ಆರ್ ಸ್ಟೇಬಲ್ ಆ್ಯಂಡ್ ದೇರ್ ಫೋರ್ ದಟ್ ಈಸ್ ರೈಟ್. ಆಮೇಲೆ ದ ಎನರ್ಜಿ ಆಫ್ 2s ಆರ್ಬಿಟಲ್ ಈಸ್ ಲೆಸ್ ದೆನ್ ದ ಎನರ್ಜಿ ಆಫ್ 2p ಆರ್ಬಿಟಲ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಲೈಕ್ ಆಟಮ್ಸ್. ಹೈಡ್ರೋಜನ್ ಲೈಕ್ ಆಟಮ್ಸ್ ಅಲ್ಲಿ ಇರೋದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್. ವೆನ್ ಓನ್ಲಿ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ದೇರ್, ಅದು 2s ಇರಲಿ ಅಥವಾ 2p ಇರಲಿ, ದ ಎನರ್ಜಿ ವುಡ್ ಬಿ ಸೇಮ್. ದ ಎನರ್ಜಿ ವುಡ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲ್, ಇಟ್ ವುಡ್ ಓನ್ಲಿ ಡಿಪೆಂಡ್ ಆನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್. ಸೊ 2s ಇರಲಿ 2p ಇರಲಿ, ಎನರ್ಜಿ ವುಡ್ ಬಿ ಸೇಮ್, ಬಟ್ ಲೆಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ದಟ್ ಈಸ್ ರಾಂಗ್. ಸೊ ನಿಮ್ಮ ಆನ್ಸರ್ ಯಾವುದು? ಆಪ್ಷನ್ ಡಿ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ನೆಕ್ಸ್ಟ್, if wavelength of the photon lambda is equal to 2.2 into 10 raised to minus 11 meter and h is equal to 6.6 into 10 raised to minus 34 joule second, then momentum of the photon is how much? So we have seen a formula in the previous equation. ಎಷ್ಟಿತ್ತದು? lambda is equal to h upon m into v ಅಥವಾ h upon p is the momentum. ಏನು ಕೇಳಿದ್ದಾರೆ? ಮೊಮೆಂಟಮ್ ಕೇಳಿದಾರಲ್ಲ. ಮೊಮೆಂಟಮ್ ಏನಾಗುತ್ತೆ? ಎಚ್ ಅಪಾನ್ ಲ್ಯಾಂಬ್ಡಾ ಆಗುತ್ತೆ. ಎಚ್ ಇಸ್ ವಾಟ್? 6.6 ಇಂಟು 10 raised to minus 34 ಆಗುತ್ತೆ. ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಹೌ ಮಚ್? 2.2 ಇಂಟು 10 raised to minus 11. 2.2 1s 3s 3 ಇಂಟು minus 11 ಮೇಲೆ ಹೋದರೆ plus 11 minus 34 should be minus 23. 3 into 10 raised to minus 23, 3 into 10 raised to minus 23, 3 into 10 raised to minus 22. Wrong. 3 into 10 raised to minus 23 kilogram meter per second. So this is what? Kilogram meter square per second or joule second. Idu irodenu? What is this? Lambda is in meter. Meter and meter gets cancelled. Nimenu ulitu kilogram meter per second. Kilogram meter per second. So therefore ನಿಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟು? 3 into 10 raised to minus 23 kilogram meter per second. ಓಕೆನಾ? ರೈಟ್. In hydrogen atom, the de Broglie wavelength of the electron in the second Bohr orbit. In the hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit. Second Bohr orbital ಅಲ್ಲಿ de Broglie wavelength ಎಷ್ಟಿದೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. Is that clear? So, and they have given Bohr radius also, a0, right? The radius of the first orbit is given in the model of the atom that is proposed by Bohr. And now we should find out the lambda. So he has connected lambda matte radius anna connect ಮಾಡಿದಾರಲ್ಲ. So we have angular moment m into v into r, which is n into h upon 2 pi. Yes or no? But ನಮಗೇನು ಬೇಕಾಗಿದೆ ಈಗ lambda ಬೇಕಾಗಿದೆ. What is lambda? Lambda is equal to for electron h upon m into v. Andre h upon mv is equal to lambda alva. So can we write h upon mv here? h upon m into v. m into v kade tandre ಏನಾಗುತ್ತೆ 2 pi kade ಹೋಗುತ್ತೆ. 2 pi into r. r for any energy level. Okay, divided by ಏನಾಗುತ್ತೆ n ಆಗುತ್ತೆ. Yes or no? h upon mv 2 pi r upon n. Okay, h upon mv is nothing but what? Lambda. So therefore what do we want to find? Lambda. So what is lambda? 2 pi radius of the nth energy level or nth orbit divided by n. But what is Rn? Rn formula ನೆನ್ಪಿಟ್ಕೋರಿ n square upon z square upon n into r naught. ಇದು radius of nth energy level. So this is the second energy level we want, no? Second Bohr orbit. Z square andre z is 1. That is 1 square. Divided by, I'm so sorry. This should be n square upon z into r naught. Yeah. So what is n here? Second energy level alva. Second energy level ge n square andre 2 square. What is z for hydrogen? Atomic number 1. And then r naught is how much? 52.9. So this is my r2 or rn, where n is 2. Okay, so lambda is equal to 2 into pi. Your Rn is how much? 2 square under 4 aitala into 52.9 divided by. So n is second energy level. 2 and 2 goes. So you're left with lambda is equal to 4949 36 333 3 4 2s are 12 and 3 andre 15 111 4 5s are 20 andre 21. So come back one digit. 415.6 into pi. These many picometer. Yes or no? Because that is 52.9 ತಗೊಂಡಿದ್ದೀವಲ್ಲ, it is in the form of picometer only. So 250.6 into pi picometer. 211.6 at 52.9. ಇಲ್ಲೆಲ್ಲೂ pi ಇಲ್ಲ. ಸೊ ಇಲ್ಲೆಲ್ಲ pi ಅಂತ ಕರೆಕ್ಷನ್ ಮಾಡ್ಕೋಬೇಕಷ್ಟೆ. ಸೊ ನಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟಾಗುತ್ತೆ ಈಗ? 215.6 ಅಂದ್ರೆ ಆಲ್ಮೋಸ್ಟ್ 211.6 pi picometer ಅಂದ್ರೆ ನಮ್ಮ ಆನ್ಸರ್ ಬಿ ಆಗುತ್ತೆ. Is that clear? So is it right here? 2 9s are, okay, there is some small error here. Small error. Pi as it is early. 4 9s are 36 3, 4 2s are 12 and 15 1, 4 5s are 20 and 21. Okay, I don't think so any error. Okay, that's fine. Almost close to the answers given. Okay. The Heisenberg's uncertainty principle will be most significant for which of the following object? For a microscopic particle, what is the Heisenberg's uncertainty principle telling you? Heisenberg's uncertainty principle tells that for a microscopic particle, you cannot determine simultaneously both position as well as its momentum accurately. If you try to find it, there will be definitely some error. So therefore, according to Heisenberg's rule, if delta x is the error in finding the position, if delta p is the error in finding the momentum, then it is at least equal to h upon 4 pi. That means there is definitely some error possible. Is that clear? So therefore, this delta x I can write delta p is what? M into delta v, we can write it h upon 4 pi. So delta x into delta v is h upon mass of the particle into 4 into pi. So delta x into delta v is inversely proportional to what? Mass. If mass is more, the error in finding these two values would be less. If mass is less, the error would be significant. So So significance of the Heisenberg's uncertainty principle would be high if mass would be less. So which is having least mass? Object A of the mass this much in kg. In gram, how much it will be? 9.11 into 10 raised to minus 27 gram. This is in gram. This is already in gram. This is in milligram, no? 9.11 into 10 raised to minus 21 gram. Yes or no? Milligram is given, divided by 1000. That should be, 27. Okay. This is in 20 kg, no? Into 10 raised to 3 would be 10 raised to minus 25 gram. So everything is in gram now. Minus 25, minus 27, minus 28, minus 27. So which is having least mass? The least mass is object B. Because the mass is the least, the significance of the Heisenberg's principle would be high. So therefore, the Heisenberg's uncertainty principle would be most significant if mass is the least. That is the option B. Is that clear, students? Right. Next. The number of angular nodes. What do you mean by nodes? Nodes are the imaginary plane where probability of finding the electron is 0. That is called as node. Angular node is on the, angular node would be in the plane of the nucleus. Radial node would be away from the nucleus. So therefore, your radial node formula is what? N minus L minus 1. Your angular node formula is what? L. The number of angular nodes and radial nodes in 3s orbital. In 3s orbital, your radial nodes ka formula, what is that? N minus L minus 1. What is N for this? 3. What is L for s orbital? 0. This is 1. 3 minus 1 is a 2. And what about the angular node? Angular nodes are just equal to L. So what is L for 3s orbital? 0. So your radial node is 2, angular node is 0. 2 and 0 is your answer. 2 and 0. First is angular node, no? First is angular node. 0 and 2 is your answer. 0 and 2 respectively is your answer. Is that clear, students? Remember those formulae. The angular momentum of the electron in the d orbital. Angular momentum of the electron in the d orbital. Angular momentum formula with respect to the azimuthal quantum number. Angular momentum formula is what? Root of L into L plus 1 into h upon 2 pi. Root of L into L plus 1. Root of L into L plus 1 into h upon 2 pi. So what is the L value? L value for a d orbital. S, P, D, F. L value is 0, 1, 2, 3. So L value for a d orbital is a 2. That should be 2 into 2 plus 1 into h upon 2 pi. 2 plus 1 is 3. 3 into 2 is root 6 into h upon 2 pi. Yes or no? So we can write it like root 6 into, we can write it h upon 2 pi like this. Right? So this is your answer. Pi is not taken to be, pi is not considered here. You can write it. Yes. This itself is h upon 2 pi. Is that clear? So option D is your answer, which we can call it as h cap, no, but this particular symbol you can refer for h upon 2 pi. Okay, right. What is the maximum number of orbitals that can be identified with the following quantum number? With this quantum number, maximum number of orbitals which can be identified. Number of orbitals depends on the values of m. m ಗೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೋ ಅಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ. Yes, m ಗೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂಸ್ ಇದಾವ? 0 is the only one value. So only one orbital. Over. Only one orbital. ಯಾವ orbital ಅದು? n is equal to 3 andre, right. L is equal to 1 andre, p orbital. So this is going to be a 3p orbital. M is equal to 0 ಅಂತಂದ್ರೆ we have m is equal to minus 1, 0, plus 1 ಅಲ್ವಾ. So ಇದು px, py, pz. So this is 3py they are speaking about. 3py is the orbital for m is equal to 0 with n is equal to 3 and l is equal to 1. So which orbital is that? Only one orbital. ಇಲ್ಲೇ ಹೇಳ್ಬೋದು ನೀವು ಡೈರೆಕ್ಟ್ಲಿ m is equal to 0. mಗೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇರ್ತಾವಲ್ಲ ಅಷ್ಟೇ ಆರ್ಬಿಟಲ್ಸ್ ಇರ್ತಾವ. ಯಾವ ಆರ್ಬಿಟಲ್ ಅಂತ ಕೇಳಿದ್ರೆ 3py orbital. Is that clear? Right. Next, which series of subshells is arranged in the order of increasing energy? Increasing energy for the multi-electron system. Right. So which are the orbital? 6s, 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 4f, 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 5d, 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 6p, 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 6p. Same or energy, same orbitals ಕೊಟ್ಟಿದ್ದಾರಲ್ಲ. 6s, 4f, 5d, 6p. How do you find the energy? Increasing order ಅಲ್ಲಿ ಬರಿಬೇಕಂತ ಹೇಳಿದಾರಲ್ಲ. How do you find the energy? n plus l rule. What is n plus l rule? n value ಎಷ್ಟಿದಕ್ಕೆ? 6. l value 0. 6. n value ಎಷ್ಟಿದಕ್ಕೆ? 4. spdf 0 1 2 3 7. 5d ಗೆ n value is 5. spd 0 1 2 7. 6p ಗೆ n is equal to 6. sp 0 1 7 7 7 6. Least value ಇರೋದು 6s ಗೆ. So 6s should be of the least energy. 6s is of the least energy. ಇಲ್ಲೇ ನೋಡ್ರಿ, increasing order ನಲ್ಲಿ ಬರಿಬೇಕಂತಂದ್ರೆ 6s is having the minimum value of n plus l. So 6s is having the minimum energy. Our answer is done. But coming to ಎಲ್ಲದಕ್ಕೂ ಇಲ್ಲಿ n plus l ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಬಂದಿದೆ ಅಲ್ವಾ, ಅವಾಗ ಏನು ಮಾಡಬೇಕು? ಯಾವುದ್ರದ್ದು n ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರುತ್ತಲ್ಲ ದಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಲೆಸ್ ಎನರ್ಜಿ. ಅಂದರೆ 6s ಆದ ಕೂಡಲೇ 4f ಬರುತ್ತೆ. 5 plus 2 6 plus 1 ನಲ್ಲಿ ಇದು ಬರುತ್ತೆ. 5 is n ವ್ಯಾಲ್ಯೂ ಇಸ್ ಲೆಸ್ ಇಯರ್ ನೋ, 5d ಕಮ್ಸ್. ಆಮೇಲೆ 6p ಬರುತ್ತೆ. 6s 4f 5d 6p. 6s 4f 5d 6p. ಇದು ಯಾವುದು ನೆನಪು ಉಳಿಲಿಲ್ಲ ಅಂದರೆ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ 1s 2s 2p 3s 3p sfdp sdp sdp sorry sdp sdp sfdp sfdp ಇಷ್ಟು ನೆನ್ಪಿಟ್ಕೋರಿ. ಇದು 4s 5s 6s 7s. ದಿಸ್ ಇಸ್ 3d 4d 5d 6d 4f 5f. This is your 4p 5p 6p 7p. ನೋಡ್ರಿ, ಲಾಸ್ಟ್ ಬರೋದು ಯಾವುದು? 6p ಅಲ್ವಾ? ಔಟ್ ಆಫ್ ಆಲ್ ದಿಸ್ 6p ಲಾಸ್ಟ್ ಬರುತ್ತಲ್ಲ, ಎಸ್ 4th ಬರುತ್ತೆ ಇದು. ಆಮೇಲೆ 5d ಎಲ್ಲಿ ಬರುತ್ತೆ? ಎಸ್, ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಬರುತ್ತೆ, ದಟ್ ವಿಲ್ ಬಿ 3rd. ಆಮೇಲೆ 4f that would come here. ಇಲ್ಲೇ ನೋಡ್ರಿ 2, this would come first over. Is that clear? Right. Next, 4d 5p 5fs and 6p orbitals are arranged in the order of decreasing energy. ಈಗ ಡಿಕ್ರೀಸಿಂಗ್ ಎನರ್ಜಿ ಕೇಳಿದ್ದಾರೆ. ರೈಟ್, 4d 5p 5f 6p n plus l value. This is n value ಇಲ್ಲಿ 4 ಆಗುತ್ತೆ. 0 1 2 spd ಅಂದರೆ 6 ಆಗುತ್ತೆ. ಇಲ್ಲಿ n is 5, this is 1, l is 1, right? n plus l, so this is 6. ಇಲ್ಲಿ 5, this is 3, l is 3, 8, ಇಲ್ಲಿ 6, l is 1, this is 7. Or no? So out of 4d and 5p, n plus l n value ಕಡಿಮೆ ಇರೋದು 4d ಗೆ. So 4d is having least energy. ಇವೆರಡು ರಾಂಗ್ ಆಯಿತು. After 4d comes automatically 5p. After 4d comes 5p. Out of 5f and 6p, it is 5f because n value is less. So 5f ಬರುತ್ತೆ, ಆಮೇಲೆ 6p ಬರುತ್ತೆ. ಅಂದರೆ ನಿಮ್ಮ ಆನ್ಸರ್ ಎಷ್ಟಾಯಿತು? ಆಪ್ಷನ್ ಬಿ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? Next, identify the incorrect statement from the following. All the 5d orbitals are different in size when compared to the respective 4d. 5d orbital size 4d orbital size ಬೇರೆ ಇರುತ್ತೆ because n value is different. That is right. ಏನು ಕೇಳಿದ್ದಾರೆ? Incorrect ಕೇಳಿದ್ದಾರೆ. All the 5 4d orbital have shapes similar to 3D orbitals are also double dumbbell, 4D are also double dumbbell. Shape is similar, size is not. In an atom, all the 5 3D orbitals are equal in energy. In the free state, ಯಾವಾಗ free state ಇರುತ್ತೋ ಅವಾಗ energy equal ಇರುತ್ತೆ. They are called degenerate orbitals. The shape of the dxy dy is the dzx. Double dumbbell orbitals are similar, fine, to each other, and dx square minus y square and dz square are also similar. No, dx square minus y square ಹೆಂಗಿರುತ್ತೆ? Along the x axis ಒಂದು, y axis ಒಂದು, ಇದು dx square minus y square. dz square ಹೆಂಗಿರುತ್ತೆ? Along the z axis, it will be like this. Donut shape ಇರುತ್ತೆ ಇದಕ್ಕೆ. ಒಂದು ಡಂಬೆಲ್ ಒಂದು ಡೋನಟ್ ಶೇಪ್ ಇರುತ್ತೆ ಈ ತರ. This is a dz square. Is that clear? They are not similar, so therefore this is wrong. The wrong one is the right answer. Yes or no, students? Next. Maximum number of electrons in the subshell of an atom is determined by following. Maximum number of electrons in the subshell. Subshell andre value of L kottaga maximum number of electrons estirutte. You should know that maximum number of electrons given is 2 into 2L plus 1. ಈ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಲಿ. Is that clear? Maximum number of electrons in a subshell. Subshell ಅಂದ್ರೆ value of L ಕೊಟ್ಟಾಗ ಅಂದ್ರೆ 2 into 2L ಎಷ್ಟಾಗುತ್ತೆ ಸ್ಟೂಡೆಂಟ್? ಇದು 2 into 2L is 4L. 4L plus 2 ಆಗುತ್ತೆ. 4L plus 2 ಅಂದ್ರೆ ಯಾವುದು? ಆಪ್ಷನ್ ಡಿ. Is that clear? Right. Next. Orbital having 3 angular nodes and 3 total nodes. 3 angular nodes and 3 total nodes. Angular nodes formula ಏನು? L. Total nodes formula ಏನು? N minus 1. Radial nodes formula N minus L minus 1. ಅದನ್ನು ಕೇಳಿಲ್ಲ, ಬಿಟ್ಬಿಡ್ರಿ. 5p ಅಲ್ಲಿ ನೋಡ್ರಿ. 5p ಅಲ್ಲಿ angular nodes ಎಷ್ಟು ಇದಾವ? L ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು 5p ಗೆ? SNP. P ಆರ್ಬಿಟಲ್ಗೆ L ವ್ಯಾಲ್ಯೂ 1. ಅವ್ರೇನು ಕೇಳಿದ್ದಾರೆ? 3 angular node ಕೇಳಿದ್ದಾರೆ. ರಾಂಗ್. 3Dಗೆ L ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? SPD 0 1 2. L ವ್ಯಾಲ್ಯೂ 2 ಬರುತ್ತಲ್ಲ. ಸೊ ಆಂಗ್ಯುಲರ್ ನೋಡ್ಸ್ 2 ಬರೋದಿಲ್ಲ ಇಲ್ಲಿ, 3 ಬರೋದಿಲ್ಲ, ಸಾರಿ. 4Fಗೆ L ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? SFDP. ಸಾರಿ, we have SPDF 0 1 2 3. so L ವ್ಯಾಲ್ಯೂ ಫಾರ್ F is 3. ಎಷ್ಟು? ಆಂಗ್ಯುಲರ್ ನೋಟ್ಸ್ 3 ಬಂತಲ್ಲ ಇಲ್ಲಿ. 3 ಟೋಟಲ್ ನೋಟ್ಸ್ ಬೇಕು ನಮಗೀಗ. 4Fಗೆ ಟೋಟಲ್ ನೋಟ್ಸು N minus 1. N ವ್ಯಾಲ್ಯೂ 4 minus 1. 3 ಟೋಟಲ್ ನೋಟ್ಸು, 3 ಆಂಗ್ಯುಲರ್ ನೋಟ್ಸು ಫಾರ್ 4F. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಫಾರ್ 4F L ವ್ಯಾಲ್ಯೂ 3 ಅಲ್ವಾ? L ವ್ಯಾಲ್ಯೂ 3 ಅಂದರೆ ಆಂಗ್ಯುಲರ್ ನೋಡ್ ಇಸ್ 3. ಟೋಟಲ್ ನೋಟ್ಸ್ ಇಸ್ N minus 1. N is 4. 4 minus 1 is 3. 3 ಟೋಟಲ್ ನೋಡು, 3 ಆಂಗ್ಯುಲರ್ ನೋಡ್ ಇರೋದು 4Fಗೆ ಮಾತ್ರ. 4Fಗೆ ಮಾತ್ರ. ಓಕೆ? ಎಸ್. ನೆಕ್ಸ್ಟ್. Which one is the wrong statement? ನೋಡ್ರಿ. The total orbital angular momentum of the electron in S orbital is equal to 0. Electron in the S orbital ಗೆ angular momentum is 0. What is angular momentum? How do you find? Root of L into L plus 1 into H upon 2 pi. S orbital ಗೆ angular momentum quantum number L is equal to 0 alva. L is equal to 0 andre all this becomes 0. So this is right. Statement is right. An orbital is designated by 3 quantum number while the electron is designated by 4 quantum number. For example ನೋಡ್ರಿ, ಇಲ್ಲಿ 3p orbital ಇದೆ ಅಂತ ಅನ್ಕೊಡ್ರಿ. ಇದಕ್ಕೆ n ವ್ಯಾಲ್ಯೂ, L ವ್ಯಾಲ್ಯೂ, m ವ್ಯಾಲ್ಯೂ, s ವ್ಯಾಲ್ಯೂ. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. As far as 3p orbital is concerned, n is equal to 3, L is equal to 1, m can be what? minus 1 ಇರಬಹುದು, 0 ಇರಬಹುದು, ಪ್ಲಸ್ 1 ಇರಬಹುದು. ಎಸ್ ಆರ್ ನೋ? ಸೊ ಅಲ್ಲಿ ನಮಗೇನು ಬರುತ್ತೆ? PX, PY, PZ ಬರುತ್ತೆ. ಸೊ ಯಾವ ಆರ್ಬಿಟಲ್ ಅದೇ ಅನ್ನೋದನ್ನ ಡಿಸೈಡ್ ಮಾಡೋದು N, L ಆ್ಯಂಡ್ M. ಯಾವ ಆರ್ಬಿಟಲ್ ಅಂತ ಡಿಸೈಡ್ ಮಾಡೋದು. ಬಟ್ ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು ಎಲೆಕ್ಟ್ರಾನ್, ಈ 4 ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಬೇಕು. ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಸ್ಪಿನ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ ಕೂಡ ಬೇಕು. ದಟ್ ಇಸ್ +12 ಆ್ಯಂಡ್ -12. ಸೊ ಆರ್ಬಿಟಲ್ ಅನ್ನ ಡಿಸೈಡ್ ಮಾಡೋದು N ವ್ಯಾಲ್ಯೂ, L ವ್ಯಾಲ್ಯೂ ಆ್ಯಂಡ್ M ವ್ಯಾಲ್ಯೂ. ಎಲೆಕ್ಟ್ರಾನ್ ಬಗ್ಗೆ ಹೇಳೋದು ಆಲ್ ದ 4 ವ್ಯಾಲ್ಯೂಸ್. spin quantum number is also required. So that statement is also right. The value of m magnetic quantum number for dz square is 0. Ille nodri m values ಏನು ಬರ್ತಾವೆ d orbital ಗೆ -2 -1 0 +1 +2 5 ವ್ಯಾಲ್ಯೂ ಬರ್ತಾವಲ್ಲ 5 d orbitals ಗೆ. ಸೊ ದಿಸ್ ಇಸ್ ಫಾರ್ dx ಸ್ಕ್ವೇರ್ ಮೈನಸ್ y ಸ್ಕ್ವೇರ್, ಇದು dxy, ಇದು dz ಸ್ಕ್ವೇರ್, ಇದು dyz, ಇದು dxz. ಸೊ ಫಾರ್ dz ಸ್ಕ್ವೇರ್ ಗೆ m value is 0. So this is also right. Electronic configuration of nitrogen atom 1s2 2s2 nitrogen atomic number s2 7 alva, 1s2 2s2 2p4, but elinide sorry 1s2 2s2 2p3, sorry. If it is 2p3, first all of the electrons should be having parallel spin alva, 1 2, but this is the reverse like this, so this shouldn't be the thing. According to Hund's rule of maximum multiplicity, all of them should be singly occupied, right, but all of them should be parallel. All of them should be parallel. Is that clear? So therefore illenagatte 1s2 2s2 2p3 is correct, but the electron is in anti-parallel direction, and therefore this is wrong. Yavadu wrong anta kelidare, this is wrong. Ivella right idavalla, these are not the right, these are the right statement but wrong answer, wrong statement but right answer. Is that clear, students? Right. So that's all for Super 30. All the 30 questions based on atomic structure. So quite quality of questions are there. So go through all of them, refer to them, read theory, and then refer to them. You will understand it better. So I'll see you all in the next class. Bye everyone.